We're going to write some molecular formulas given for these four chemical structures here. Molecular formulas tell you the atoms that are present, the quantities that are present, and tells you a little bit of structural information here. This first element is this first molecule or compound is carbon dioxide. It has one carbon and two oxygens. Carbon is an important molecule in the chemistry of life. So we write that atom first, and then we put the oxygens second and write it as CO2, order that is very familiar to you. If you were to ever to see it written as O2C, that would be either incorrect or that author is doing something very, very, very specific to highlight the oxygens. But you're never, that's a very rare occurrence there, because in our language of chemistry, that's something we ain't doing too often. This down here is sulfuric acid. It is S, sulfur in the middle. There are 4 oxygens on the outside, and there are 2 hydrogens, H2. This is at this level in Gen Chem, this is a perfectly acceptable way to write out the molecular formula for this compound here. This will not be what you see in a lot of different answer keys and setups right here. And that is because the formula will sometimes highlight some of the structural or chemical properties of the molecule. Sulfuric acid, so once you've heard that, you can probably guess is an acid. So because it is an acid, we try to display that to the reader by putting the hydrogens first. And we'd say H2SO4. There's a little bit of a poem in the chemistry lab that Sally drank H2SO4 and then was no more. Just kind of highlighting the danger of ingesting it right here. Now this molecule here, disilicon tetrachloride, whatever, we're just going to write the formula for this. There's 2 silicons in here, Si2. There's 4 chlorines, Cl4, and there are 2 hydrogens, H2. This again is a formula that just shows the quantity right here. The order may be different because the author may be trying to highlight a structural or chemical property. This right here, these formulations, that's great for right now. This right here is a little bit of organic chemistry. In organic chemistry, we are lazy about drawing our carbons and our hydrogens. So you do not see letter C's or letter H's. Because we don't see any letters, only carbon and hydrogen are in this molecule right here. Carbon is pretty much every corner and nook in a stick picture like this. So there are every corner and nook is 1, 2, 3, 4. There are 4 carbons in this structure right here. This is lazy. We're lazy about drawing the carbons. We're also lazy about drawing the hydrogens. Carbon, 99% of the time, bonds 4 times and 4 times max. So if we don't draw hydrogens there, it is up to the reader to interpret the hieroglyphics and fill in the hydrogens with their imagination or a pen. I'm going to fill in the hydrogens with the pen. This carbon here bonds 4 times. I'm going to draw the C in there. There's already 1 bond shown. So that means the other 3 bonds are bonded to hydrogen atoms. This carbon here is only bonded twice. So it has 2 more bonds to hydrogens. Right now we have 5 hydrogens total. This carbon here is already bonded 1, 2, 3. So we got to give it 1 hydrogen bond. This terminus carbon here is already bonded, you said it, twice. So it needs dose more carbons. Excuse me, hydrogens. For right now, I encourage you to draw in the carbons and hydrogens until your atomic vision kind of fills them in right there. And it never hurts to draw them out because your finger is a lot better at counting than your mind. So right now we have 5, 6, 7, 8. C4, H8. Thank you.